Okay, hello students and welcome to today's math happy hour for the NCBN 0324 and for the math 1324. Today's topics are going to be solving systems of linear equations. This covers, I believe, sections 6.1 to section 6.2. Okay. Okay, now, so to start off, it says here solutions of a system of linear equations. Determine whether the given order list of numbers is a solution of the systems of equations. So what does this mean? Okay, this means that I'm going to go, right, I'm going to call these equations 1 and 2. This number here, the order pair, the -1, 3, must be true for both of these equations for this to be the solution of this order, the solution for the systems of equations. So I'm going to go first and plug in -1, 3 in equation number 1 for the x and the y. Right, so here my x is -1 and my y is 3. So this becomes, right, -2 plus 3, it becomes 1 equals 1. So this makes this equation number 1 true. But for the point, the -1, 3, for it to be a solution, it has to be true for both equations. So now since it's true on the first equation number 1, then we can proceed to equation number 2. So again, we're going to plug in -1 for x and 3 for y. If you notice, this gives us 9 equals 9, so this is true, which means since the order pair -1, 3 makes both equations true, then the order pair is a solution. Now we repeat the process for number 2, but we have different equations and a different order pair of numbers. So again, I'm going to go to equation 1. I'm going to plug in 2 for the x and -0.5 for the y. This gives us 1 minus 4. This gives us -3 equals -3. So this is true, right? So then I go to equation number 2. And I repeat, I'm going to plug in the 2 for the x and the -0.5 for the y. Here it's going to give us -0.5 equals to -5. This is not true, right? Because -0.5 does not equal to -5. That means that this is not, since the order pair 2 -5 does not make both equations true, then the order pair is not a solution. So the summary of this first slide, equation, on number 1, that's true. Yes, it's a solution, and number 2 is not a solution. Okay. Now, systems of two linear equations in two variables. There's going to be the graphing method, the elimination method, and the substitution method. In this particular chapter, we don't do it by graphing, but you can if you wanted to. Okay, here's an overall picture of really what we're looking for. For example, we're looking for the point where the two lines or the two equations intersect. This means one solution. If you have, right here we have two lines, the -4x plus y equals 2 and 8x minus 2y equals -4, right? We have two equations, but they're the same line. That means there's going to be infinite solutions. And here on figure C, we have -6x plus 4y equals 7 and 3x minus 2y equals 4. So these two lines, they never intersect. They're a parallel line. So for this one, there's no solution. Okay, and this is something from chapter 2. But I repeat, we're not going to be graphing in this section, but I'm still going to do one with graphing just so you know that we get the same solution. Now, for example, if we have one solution, you're going to get something like x equals to a or y equals to b. That means that x equals to a number like x equals 3 or y equals -2. That's a key, a key point that there's going to be one solution. Now, if we get infinite solutions, you're going to get something like a equals to a, like 3 equals 3 or 0 equals 0. That means that it's going to be infinite solutions. And in this situation, there's not going to be no x nor no y. You see, but this is true, right? Like 0 equals to 0. Now, on part C, right, on the last one, figure C, you're going to get something like a equals b, which means that let a and b be real numbers. For example, 3 equals to 4, right? There's no solution because 3 does not equal 4. And again, on this situation, there's going to be no x nor y. Right now, you might be a little bit confused at what I mean by that, but once I do some examples, it's going to make sense. Okay. If you have one solution, it's called consistent independent system. If you have infinite solutions, it's going to be consistent dependent system. And if there's no solution, it's going to be inconsistent system. Okay, now, I repeat, you guys don't have to graph them in this section, but I'm going to graph it anyway, just so you know. I'm going to do this one by 3 different methods: by graphing, by substitution, and also by the elimination method, and we're all going to get the same answer. Okay? First, by graphing. If you have equation 1 equals to y equals to 3x minus 6, right? We know that my slope is 3, which would be 3 over 1. And my y-intercept on my b is negative 6, which is 0, negative 6, and this is my starting point, right? So the b is my starting point, so we're going to start at 0, negative 6, which means we're going to start here at the bottom, 0, negative 6. And then we're going to go up 3, because my slope is 3, so it means it's going to go up 3, up, and 1 to the right. So we're going to go up 3, 1, 2, 3, and 1 to the right. And we connect the points. So it gives us that line. Now we're going to graph equation number 2. To graph it in the slope-intercept form, we have to rewrite it, okay? Because this equation is not in that form in y equals to mx plus b. So I have to rewrite it by first adding 5x to both sides. And then we divide every term by negative 2. Now it's in the slope-intercept form. So my slope is negative 5 over 2, and my b is 5, which is my y-intercept will be 0, 5, and this is my starting point. So we start at 0, 5. So we're going to go up here at 0, 5. Then, right, the slope is negative 5 over 2. That means I'm going to go down 5 and 2 to the right. 1, 2, 3, 4, 5, and 2 to the right. 1, 2. There's my point. We connect the 2 points. And there's my other line. And where do both lines intersect? They intersect at 2, 0. So this is my solution. Okay. Now I'm going to do it again. This very same problem, but not by graphing, but by substitution. Okay. Now, by substitution, you want to get one of the variables, the x or the y, that's isolated or by itself. If you notice on equation number 1, we have y already by itself, right, or isolated. We have y equals to 3x minus 6. So I'm going to use that, the y equals to 3x minus 6, and plug in 3x minus 6 on equation number 2. Okay, I'm going to substitute 3x minus 6 for the y on equation 2. Right? So I'm going to plug in the 3x minus 6. Now I'm going to distribute, right? For example, here, right, we have negative 5x, and we multiply negative 2 times 3x will give us negative 6x. If we multiply negative 2 times negative 6 will give us a positive 12. Now we're going to combine the like terms. Okay? For example, negative 5x minus 6x will give us negative 11x plus 12 equals 10. Now we subtract 12 from both sides. It's going to give us negative 11x equals to negative 22. Now we divide both sides by negative 11. So x equals 2. Now we need to find the y value, right? Because for the point of intersection is an ordered pair. It has an x and a y. So now to find the y value, we need to go back to either equations 1 or 2 and plug in the 2 for x and solve for y. Whatever is easier for you. Okay, in my opinion, it's easier to go to equation number 1. Why is it easier? Because the y is already isolated. So all we need to do is plug in the 2 for the x is, and we have the value for y. This gives us y equals to 6 minus 6, y equals 0. So here, guys, I found my x and I found my y. So this is my solution, 2, 0. Okay, now, hey guys, in this book, guys, they only give you like 2 examples of each one. Okay? Because they assume that you guys should know this by now from high school. or maybe from the SMBN class. Okay, but anyway, guys, you guys can always come back to this PowerPoint, and actually it can help you work some of these problems out. So now I'm going to do the very same problem, but we're going to do it another method. This is called by the elimination method. Okay. Hey guys, to solve by using the elimination method, both equations must be in the form of ax plus by equals c. Okay. So if we notice, equation number 1 is not in this method, in the ax plus by equals c. So I need to rewrite it in proper form. So here, guys, all we do is send the 3x to the left by subtracting 3x to both sides. Now equation number 1 is in proper form. Okay, now here is where we have to eliminate either the x's or the y's. Whatever is easier for you. Okay, I'm going to do the very same problem. I'm going to do it in 2 different ways. The first way is I'm going to eliminate the y's, which is much easier than the x's. And then on the next slide, I'm going to eliminate the x's first. Okay, just so you know that you get the same result, but by doing it by eliminating the x's is a little bit more work. Okay, for example, to eliminate the y's, right? This on equation 1, and there must be a 2 there, right? Like a 2y. That way they can be eliminated. So I need to multiply the whole equation by 2. Right? If we multiply 2 times negative 3x will give us negative 6x. And 2 times y will give us positive 2y. And 2 times negative 6 will give us negative 12. So equation number 2, all we do is bring it over, slide it over. You see, guys, if you notice, the y's will be eliminated. So we have negative 6x plus negative 5x will give us negative 11x equals to negative 22. Then we divide both sides by negative 11. So we get x equals 2. Now, to solve for y, we do the very same thing as what we did it when doing it by the substitution method. Since we got one of the values right, then we have to go and plug in this case, the 2 for x in either equation 1 or 2, whatever is easier for you. In my opinion, guys, it's easier to go to number 2. Okay? Or number 1, I mean. Because x is already 2, right? Because the y is already isolated, so we're going to plug in the 2 for the x's. So we get 0. You see, guys, we get the same thing, right? I did it by graphing. We got to 0. We did it by the substitution. We got the same solution to 0. And now, by elimination method, we got the same solution, which is 2, 0. And this is called a consistent independent system, right? Because we have a solution. Now, I'm going to do the very same problem again, but doing it by eliminating the x's first. Okay, so repeat the process as before. Right now, here, guys, instead of getting rid of the y's, I'm going to get rid of the x's. So here it's a little bit more work, okay? Because I need to multiply equation number 1 by negative 5 and equation number 2 by 3. Why? Because this guarantees that it's going to give me a positive 15x and a negative 15x. You see, guys, for example, negative 5 times negative 3x will give us a positive 15x. Negative 5 times a positive y will give us a negative 5y. And negative 5 times negative 6 will give us a positive 30. And equation number 2, 3 times negative 5x gives us negative 15x. 3 times negative 2y gives us a negative 6y. And 3 times negative 10 will give us a negative 30. Right? After we add them, right, it's going to give us negative 11y equals to 0. Divide both sides by negative 11, so we get y equals 0. So I got my y value. Now I need to find my x value. In this case, right, again, I'm going to go back to equations 1 or 2 and plug in the 0 for y. Okay, whatever is easier for you. In my opinion, guys, it's easier to go to number 2. Right, so we're going to plug in 0 for y. Then we divide both sides by negative 5. So we get x equals 2. There's my solution, guys. You see, I repeat, I did it 3 different ways, and we get the same solution. So there's different ways to find the answer. For example, when I give the exam on this particular chapter, on number 1, I tell the students to do it by substitution. And if they don't do it that way, I'm going to count it wrong. And then on number 2, I tell them to do it by the elimination method and so forth. Okay? If the instructors tell you to do it a particular way, you have to do it that way. But if they don't specify what method to use, then you can do it any way you want, what's easier for you. Okay? Okay, now. Hey guys, remember that I said, let me go back. Let me go back to the previous slide. Remember at the beginning, guys, when there was like those 3 graphs, and there was when 2 lines were crossing. Remember when I said if you get x equals to a number, right, or y equals to a number. For example, here we got y equals 0, so that's a heads up that we're going to have one solution. Now the next scenario is like having 0 equals to 0 and no x or y's. This would be infinite solutions. This is an example of the second graph that we went over, I think, on slide number 2. So for example here, guys, right, we have to eliminate the x's or the y's. So I'm going to eliminate the x's by multiplying the first equation by -2. Now -2 times 3x will give us -6x. -2 times -2y will give us a positive 4y. And -2 times 4 will give us a -8. Equation number 2, all we do is slide it over. If you notice, everything got eliminated, right? This was like a case, like I went over, it was a second graph in the middle where there was a line on top of a line. This is called infinite solutions, okay? And it's called a consistent dependent system because y depends on x. Now this is a scenario of the third one on the graph, right? Remember there was no solution, and here's how it looks like. So again, I'm going to eliminate the x's. I'm going to multiply by -3. This gives us -6x minus 5y equals to -24 if I multiply -3 times every term on equation number 1. Equation number 2, all we do is bring it over. So we get 0 equals to -6. If we notice, right, there's no x's or y's. But 0 does not equal to -6. Therefore, there's no solution, which means the lines will never intersect. The lines are parallel. That's what that means. And this is called an inconsistent system because there's no solution. Now, how does these problems relate to the real world? Here's an example. Okay? It says here, a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? Okay? Here's the solution. We need to find 2 equations. Okay? So like I tell my students, this is a 200-seat theater, so we're going to do seats with seats and money with money. What does that mean, seats with seats? This is what it means. Let x equal to adult seats and let y equal to children's seats. And there are 200 total seats, so it's going to be x seats plus y seats equals to 200 seats. So it'll be x plus y equals to 200. The first sentence is my first equation. Now, my second sentence will be my second equation, right? So check this out. It says here, how much are the adult tickets? Right, $8. So if x represents adults, then this will give us 8x. How much were the children's tickets? $5, right? If y represents children's tickets, then this will give us 5y. What was the total income? Was $1,435. Here's what we get, my second equation. So it's going to be 8x plus 5y equals to 1,435. So I found my both equations. Now we're going to solve it by the elimination method because it's easier, right? Which means I'm going to get rid of the x's. Well, I mean, here, guys, it doesn't matter what you want to get rid of. You get the same answer. But to start off, I want to get rid of the x's. So I'm going to multiply the first equation by -8. If I multiply -8 times every term on equation 1, it's going to give us -8x minus -8y minus 8y equals to -1600. Equation number 2, all we do is bring it over. Then we add them. right? If you notice, the x's were eliminated. So negative 8y plus 5y gives us negative 3y. Negative 1600 plus 1435 will give us negative 165. We divide both sides by negative 3, and the result will be y equals to 55. We got the y value right now. I need to find my x value. So I need to go and plug in 55 on y on either equation 1 or 2. What's easier will be equation number 1. Right, so we know that y value is 55. So we plug it in there, and we subtract 55 from both sides. So we get x equals to 145. So then what's my answer? What are we looking for? What we're looking for is how many adults and how many children's seats were in available. I mean, how many adults and how many children were in the audience. So if x represents adults and y represents children, so then there must be 145 adults and 55 children at the theater. Okay, that's how you do these type of problems with two equations with two variables. This covers section 6.1. Now comes 6.2. 6.2 is called larger systems of equations. Okay, now they're going to give us three equations with x, y, and z and a constant. So there's got to be some sort of a plan, right, to solve for x, y, and z. And here's a plan. Okay, we always want to have at the top equation number 1 an x with a coefficient of 1, or an x with no number in front, which means a coefficient of 1. So at the beginning, you can rearrange them. So I'm going to switch equation 1 and 2. Right, if we notice, equation 2 became number 1, and equation 1 became number 2. Okay, now here's a plan. Hey students, if you follow this plan that I came up with, you can never go wrong. You always apply it, okay? And it's very simple to follow. You're going to take equation 1 and equation 2 and get rid of the x's. And also equations 1 and 3 and eliminate the x's. That's the first part. I repeat, you get equation 1 and 2 and 1 and 3 and eliminate the x's. After you do that, you can have a new equation 2 and a new equation 3. Then I'm going to get the new equation 2 and the new equation 3 and eliminate the y's. Then after that, you're going to get something like z equals to a number to c, and c is a real number. After you make all these executions, this is what your equation should look like. You see, this is equation 1. Equation 2, we got it from here, right? From the second step. And equation 3 was when z equals to a number. So I'm going to show you how to go from here, right? From the three equations to something like this at the bottom that you'll be able to use back substitution. Okay, here we go. Right, so here's the plan. I'm going to get equations 1 and 2 and get rid of the x's. So I need to multiply equation 1 by negative 2. Again, why negative 2? Because negative 2 times x will give us negative 2x. Then when added to the second equation, the x's will be eliminated. But I need to multiply negative 2 times every term on equation number 1. Right? So negative 2 times x will give us negative 2x. Negative 2 times negative 3y will give us positive 6y. And negative 2 times positive 2z will give us a negative 4z. And negative 2 times 0 will give us a 0. Equation number 2, all we do is slide it over, and then we add them. So this is my new equation number 2. Now, I'll repeat the process, but we're going to be using equations 1 and 3. So I'm going to multiply equation number 1 by negative 3. All right, after we do that, this is what we should see. negative 3x plus 9y minus 6z equals to 0. And then equation number 3, all we do is slide it over. And then we add them. If you notice, the x's are also eliminated. So this becomes my new equation number 3. Now I'm going to get the new equation 2 and the new equation 3, and we're going to get rid of the y's. Okay? Most most instructors and also the book might tell you here to find the least common multiple between 4 and 10, which is 20. But I don't do it that way, guys, because I don't want to feel. I don't want to leave no student now, because some students, they don't know what the LCMS is, which is the least common multiple that both 4 and 10 can go into. So therefore, I don't do it that way. I just say, since these two are right to eliminate the y's, they're both positive, so I need to multiply one by a negative and one by a positive. So what I'm going to do, I'm going to multiply the coefficient on 3 on number 2, right? But it's going to be negative 10. Then I'm going to multiply the coefficient on number 2 by number 3, which will be 4. Why is that? Because negative 10 times 4y will give us a negative 40y plus 30z equals to negative 30. And then when I multiply the 4 times equation number 3, on the y is going to give us a positive 40y minus 28z equals to 28. If you notice, the y's are now eliminated. So we're going to get 2z equals to negative 2. Now we divide both sides by 2. Z equals to negative 1. And if you notice, we get the same equations that we had on the previous slide. Now we're going to back substitute. I was going over this in class today, and the student mentioned, Mr. Isasi, do we have to use equation 2 as here for equation? No, you can also use equation 3 if you want. If you want to, you can use 10y minus 7z equals 7 for equation number 2. It doesn't matter which one you use. But since this one's called the new equation 2, I use that one. But you can use also equation 3 on number 2. But the last equation must be z equals to negative 1. Okay? Now, I'm going to go now, because we already know what the z is, right? I need to solve for y and for x. So then to solve for y, I'm going to go to number 2. I'm going to plug in negative 1 for z. And all we do is, after that, right, we simplify, and we're going to get for y equals to 0. Right? And then we divide both sides by 4. So after that, right, so we're going to get y equals to 0. So I already have my z and my y. Now I'm going to go to number 1. I'm going to plug in the value for y and z on equation number 1. Right? My y is equal to 0, so I'm going to put in 0 for the y is. And my z is negative 1. I'm going to plug in negative 1 where the z is. So now this comes out to x minus 2 equals 0. So to solve for x, I'm going to add 2 to both sides. So we know that x equals to 2. So I found I found the solution, which is 2, 0, negative 1. This is my solution for solving the systems of equations. Okay, now I truly believe this is the hardest part of I think of this chapter, or maybe even the entire book. Most students would not need to know the Gauss-Jordan method, but if you go in for computer science, I'm not computer science, for accounting or for business, you have to know the method, because this is explained at the very beginning of the chapter when you start 1325. Okay. Well, anyway, this is called the Gauss-Jordan method, and this is the objective. Okay, they're going to give you linear systems of equations, which will be 3 equations. Then you're going to have to rewrite it as an augmented matrix. And then comes the reduced row echelon form. The RREF stands for Reduced Row Echelon Form. What does that mean? It means, right, here's my system of equations. To put it in an augmenting matrix, right, if you notice, we only get the coefficients. You see, these are the x's, the y's, the z's, and the constants. So we know that the x equals to 1, the y, the coefficient will be -3, the z's will be 2, and it will be 0. So for the next one, it's going to be 2, -2, 1, 3. And lastly, for the third equation, it's going to be 3, 1, -1, and 7. Now, this must be executed, and this should be the end result. This is my solutions: 2, 0, -1. But you may be thinking, how are we going to do it? Right? This is the question: how? So anyway, I came up with updated or the modified version of the Gauss-Jordan method. This modified version that I came up with, there's no fractions until the very end. Okay, you won't get no fractions until the very end, because at times you're going to get fractions. But if you follow this method or my updated method, there's not going to be no fractions until the very end. Okay, now I call it a 3-step plan. Okay, say for example, A through L are all real numbers, right? So to put in and reduce row echelon form, we have to go from augmenting matrix to reduce echelon form, and the answer will be x, y, and z. For example, this is my x, right? X plus 0y plus 0z equals 2x. This will be my y, 0x plus 1y plus 0z equals y. And lastly, 0x plus 0y plus z equals z. In other words, this is a value for x, this is a value for y, and this is a value for z. Whatever this is here will be the values for x, y, and z. Okay, now here's the 3-step plan. Okay, that's why I only use 3 matrices, and that's it. But every step has 2 parts. This is considered row 1, row 2, and row 3. So I even color-coded it, so you see, right, step 1 is in blue. Step 2 will be in green, and step 3 will be in red. So for step 1, right, the 1 and the the E and the I must be zeros, right? You see, these two must be zeros. And then step 2, right, in green, then my B and my Q, whatever the place value for B and the Q are, those might be zeros. That means that row 1's got to change, and row 3's got to change. And then step 3 will be in red. In step 3, my U, right, for the U is and the N is must be 0, so these two must be eliminated. So I'm gonna modify row 1 and row 2, right? And after I execute those operations, we're gonna get something like, right? And then this is simplify as possible as you do each step, which I'm gonna do when I do an example. This is how you should look after you execute step 3. If you notice, if you do it this way, guys, there's only 3 matrices, 1, 2, 3, and then you get your answer. The book has about like 6, 7, 8, or 9, even more than that. Also, when instructors teach this, they also have a whole bunch of matrices, because for each one, they do a step. And if you follow my way, guys, it's only 3 matrices, and it's not that time consuming, and also you don't use a lot of matrices. Okay, here we go. Now, when the students, they get intimidated by variables, by letters. So I use number signs. Okay, and you see, I'm going to do the very same thing, but just with number signs. See, step 1, these must be zeros. Step 2, these two must be zeros. Step 3, right, these two here must be zeros. Right, and somebody asked me, I think last semester, Mr. Sassi, well, what do you put out number signs for? Because a lot of students, like I said, a lot of students are not traditional students. They haven't been in school in a long time. For example, when I came back to school, I was 43, and to me, it was intimidating coming back to school. When I would see a lot of letters, I would get confused, because I was already, by using X and Y and Z, right, there was already enough letters, but now using A, B, C, and other letters, to me, that confused me. That's why I use number signs, because I don't want no student to be left behind. For example, I mean, this way, this is like watered down to anybody's level. And I did it both ways, by the concept and now by using number signs. Anyway, guys, so let's do this problem here. Okay, here we go. Okay, we're going to do it. I'm going to do each step, one slide for each step. So this will be my solution. Okay, 2, 0, 2, 0, negative 1 is my solution. So first, I'm going to do step 1 here, right? This is row 1, row 2, and row 3. So step 1, for the right, step 1, right, I'm going to keep row 1. So row 1 stays the same. Where the 2 is, right, because step 1, right, is in blue up here, color coded. So step 1, where the 2 is, must be a 0, and also where the 3 is, must be a 0. That's why I have to change row 2 and row 3. Okay? Okay, now we're going to use row 1. So I need to multiply -2 times row 1, right, and add it to row 2. This way, the where the 2 is going to be a 0. So it's going to be -2 row 1 plus row 2. Then in a similar fashion, I'm going to multiply -3 times row 1 and add it to row 3. Right? And here's my work. -2 row 1 equals to -2 times everything in row 1, which is 1, -3, 2, and 0. So after I execute that, it's going to give us -2, 6, -4, and 0. Then I'm going to add it to row 2. Row 2 is 2, -2, 1, and 3. You see, after we add them, right, where the 2 was, it became a 0 now. So this is my new row 2. Why? Because -2 plus 2 will give us a 0. 6 minus 2 will give us a 4. -4 plus 1 will give us a -3. And 0 plus 3 will give us a 3. Now we'll do the same thing for the second part. So -3 row 1, right, will give us -3, +9. -3 times 2 will give us -6. -3 times 0 will give us a 0. And then we're going to add it to row 3. So row 3, guys, all we do is bring it over. We add them. And here's my solution. We got 0, 10, -7, and 7. That's my new row 3. This is step 1. Okay, on the next slide, I'm going to start step 2. Right, so I'm going to put this, guys. So this here, guys, is what we're going to put on the next slide. There it is, right? This was the answer for step 1. Now, step 2. Step 2, guys, right, it's in green. So that means that step 2, we're going to keep row 2. So where the -3 is, right, must be a 0, right? Where the -3 must be a 0. So that means we're going to do something in row 1. And where the 10 is, it's going to be a 0. That's why I put it in green. So we're going to do something in row 3. So where do we get these numbers from? Okay. Let me go back. Okay, now I'm going to use the 4, right? So we get the -3 and the 4. So I'm going to multiply equation 2 by 3 and equation 1 by 4, right? Because this will guarantee that it's going to be a 0 where the -3 is. Okay, let me show you what I mean by that. And then for the second part, since it's both positive, I need to multiply one by a negative. So I'm going to multiply where the 4 is, which is row 2 by -10, and row 3 by 4. Okay, let's do the first part first. So 3 times row 2 equals to 3 times 0, 4, -3, and 3. It's going to give us 0, 12, -9, and 9. Plus 4 row 1. Now I'm going to multiply 4 times everything in row 1, which will give us 4, -12, 8, and 0. Because 4 times 1 is 4. 4 times -3 is -12. 4 times 2 is 8. And 4 times 0 will give us 0. Right? So this gives us 4, 0, -1, and 9. That's my new row 1. Now this is my second step, or my second part for step 2. Negative 10 times 0, negative 10 times row 2 will be negative 10 times 0, 4, negative 3, and 3. That gives us 0. Negative 10 times 4 will give us negative 40. Negative 10 times negative 3 will give us positive 30. And negative 10 times positive 3 will give us a negative 30. Now we do the 4 row 3, right? So 4 times row 3 will give us 4 times 0, 10, negative 7, and 7. That's going to give us 0, 40, negative 28, and 28, right? After I execute the operation there, we get 2z, right? 2, 0, 0, 2, negative 2. Here, guys, is what I mean by we can simplify, right? We can divide everything by 2. If we do that, it's going to give us 0, 0, 1, negative 1. That's my new equation number 3. Now, on the next slide, I'm going to do the last part, which is step 3. So I just carry this here, guys, in blue was the answer for step 1. This was the answer for step 2 on the previous slide. Now comes the last part, step 3. So step 3, we're gonna keep row 3. And then, right, so then for the negative 1 has to be a 0. And for the negative 3 it also has to be a 0. So I'm going to execute something on row 1 and also on row 2. We're going to use row 3. So to get rid of the negative 1 in row 1, we're going to add row 3 plus row 1. To get rid of the negative 3 on row 2, we're going to multiply row 3 by 3, right? Because 3 times 1 will give us 3. When we add it to negative 3, will give us a 0. So it'll be row 3 plus row 2. And here's row 3 plus row 1 gives us 4008. Can we simplify? Yes, we can divide everything by 4. So it's going to give us 1002. That's my equation number 1. Now I'm going to do the second part on step 2. I'm going to multiply 3 times row 3 will give us 0, 0, 3, and negative 3. We're going to add it to row 2. Row 2 is 0, 4, negative 3, 3. Right, so after we add them, it's going to give us 0, 4, 0, 4. 0, 4, 0, 0, I mean. We divide everything by 4, right, because we want to, for it to be a 1 there. So we divide everything by 4, so we get 0, 1, 0, 0. You see, guys, this is my solution to 0, negative 1. That's the answer for this part here. Okay. Now, let's do one together then. Okay. So again, right. So this is step 1. Step 1, right, it has 2 parts. So where the 2 must be a 0, and where the negative 1 is on the first column must be a 0. Which means, right, step 1, we're going to keep row 1. So here, guys, I'm going to multiply negative 2 times row 1 and add it to row 2. And here, guys, right, we have 1 and we have negative 1. So all we do is going to add 1 and 3. We're going to add row 1 and row 3. And here's my work. Negative 2 times row 1 plus row 2. Right, so if we multiply negative 2 times row 1 will give us negative 2 times 1 will give us negative 2. Negative 2 times positive 2 will give us negative 4. And negative 2 times negative 1 will give us a 2. Negative 2 times 6 will give us a negative 12. We're going to add it to row 2. So we're just bringing row 2 over. After we add them, it's going to give us 0, negative 5, 5, and negative 5. And here, guys, right, we can simplify this because they'll have a 5 in common. So we can divide everything by negative 5. If we do that, it's going to give us 0, 1, negative 1, and 2. Because 0 divided by 5, negative 5 will give us 0. Negative 5 divided by negative 5 will give us 1. 5 divided by negative 5 will give us negative 1. And negative 10 divided by negative 5 will give us a 2. So this is my new row 2. The second part, we're going to add row 1 plus row 3. It will give us 0, 1, 0, 1. Okay. So we're done with part 1. Now comes part 2 in green. So for part 2, right, we're gonna keep row 2. Then where the 2 is on the first row, second column, there has to be a 0. And where the 1 is on that third row, second column, that's going to be a 0. So I'm going to do something with row 1 and something with row 3. We're going to use row 1. We're going to use row 2. Because something that you can actually can see, right? In step 1, we use row 1. In step 2, we use row 2 to get rid of the other 2. In step 3, we're going to use row 3. So here, guys, in step 2, we're going to use this one in row 2 to get rid of the 2. To get rid of the second column, the 2 and the 1 on equations 1 and 3, on row 1 and 3. So we're going to multiply -2 times row 2 and add it to row 1. And here, guys, to get rid of the 1 here, here on row 3, I'm going to multiply -1 times row 2 and add it to row 3. Here's my work. So -2 row 2 plus row 1. Right, multiply -2 times row 2 will give us 0, -2, 2, and -4. This is my row 1, right? We'll just bring row 1 over. We get 0, 1, 0, 1, 2. So this is my new equation number 1. We're going to multiply -1 times row 2 will give us 0, -1, 1, and -2. We're going to add it to row 3. So all we do is bring row 3 over, so we get 0, 0, 1, -1. So this is my new row 3. If you notice, guys, we're done with step 1, which is these two must be zeros. We're done with step 2, which these two must be zeros. And now comes step 3, where this 1 is and this -1 is, those must be zeros. So step 3, we're going to keep row 3. And where the 1 is, right here on top, that's going to change. And also where the -1 is on row 2, that's going to change. So by using row 3, right, by using this one here at the bottom, we're going to multiply this one by -1 and add it to row 1, which would be -1 row 3 plus row 1. And here, guys, if we just add these two, the row 3 plus row 2, that's going to guarantee me a 0 there. So we're just going to add those. And here's my work. So -1 row 3 will give us 0, 0, -1, and 1. And add it to row 1. Right, so this is my solution. This is my first equation 1 or row 1. This becomes 1, 0, 0, 3 becomes my new row 1. Now row 3 plus row 2, we just add row 3 and row 2. That gives us 0, 1, 0, 1. That's my new row 2. So what's my solution? Will be 3, 1, -1. That's my answer. Okay. Okay, now, how are these used in real life? Okay. Here's how we do it in real life. I think this is the last slide. Okay, it says here, number 12. Tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert. The total ticket receipts were $1,150. Then it says 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? So solution, we need to find 3 equations. Right? We need to find 3 equations. So let's see here. So again, we're going to do, let's see here. We're going to go do people with people, right? And then money with money. And then the last sentence, or the second to our last sentence, will be the third equation. So people with people, money with money. So here we go to find the first 3 equations. Adults, teenagers, and preteens, right? So all these that attended were 570. So since adults is first, I'm going to let x equals to adults. I'm going to let y equals to teenagers, and z equals to preteens. And there were 470 total people, right? So this will be x plus y plus z equals to 570. Now for the second equation, right, it's saying that adult tickets were $5. So if adults is represented by x, this should be 5x. teenage tickets were $3. And teenagers is represented by the letter Y, so this will give us 3Y. Preteen tickets were $2, right? Since Z represents preteens, it's going to give us 2Z. What was the total revenue or the total money? Was $19.50. So I found my second equation. 5x plus 3y plus 2z equals to $19.50. Now we need to find equation number 3. How do we find that? Right? So we use the second to last sentence. Here it says 3/4 as many teenagers as preteens attended. Okay? This is what it is. Since y is teenagers and z is preteens, this is what this means here. Y equals to 3/4z. But you might be thinking, how if this is difficult, write it how it sounds. Okay, this is how it sounds, and then flip it. Maybe the word flip it is not the right word to use. Okay, but this is what I mean by that. Doesn't it sound like 3/4 teenagers? So write it how it sounds. Write 3/4 y equals to z, and then you're going to put the 3/4 where the z is. That's what I mean by flip it. And again, maybe that's a wrong word to say, right? But what I mean that 3/4 goes with a z. You see, guys, we got the equation now, right? So, but now we're gonna multiply everything by 4 because we don't want no fractions. Then we're gonna send the z to the left side by subtracting 3z. So this is my third equation. That's equation number 3. Now you can do it either by matrices or by solving it. Remember the plan that I told you about, that I use 1 and 2 and 1 and 3 to get rid of the x. We can do it that way. Okay. I believe that's the way I'm going to do it. This is supposed to be my answer. Okay. Anyway, guys, here it is. Okay, so let's do how we did it before. We're going to use, because by matrix is a little bit more challenging, it's harder. So let's do it this way. We're going to get 1 and 2 and get rid of the x's. So I'm going to multiply equation 1 by -5. Right after I distribute the -5 times all those terms, it gives us -5x minus 5y minus 5z equals to -2850. We'll just bring down equation 2 over. We add them. So we got -2y minus 3z equals to -900. This becomes my new equation 2. Now, equation 3, right? It already has no x's, so I can skip that part because equation 3 doesn't have an x no more. I mean, there's no x there. So I can go straight to finding my new equation 3 and my new equation 2 and my equation 3. Here we're going to get rid of the y's. So I'm going to multiply equation number 2 by 2. Why 2? Because 2 times -2 will give us -4. Then when we add it with a 4, they'll be eliminated. Okay. So 2 times -2 will give us 2 times -2y will give us -4y. 2 times -3z will give us -6z, and 2 times -900 will give us -1800. So we got -9z equals to -1800. We divide both sides by -9, so z equals to 200. Now I found my 3 equations, right? There's equation number 1, equation number 2, and this is equation number 3. So now I'm going to go back and substitute. So to solve for y, I'm going to go to equation number 2. I'm going to plug in the 200 for z and solve for y. We add 800 to both sides, right? And then we divide by -2. So y equals to 150. So I got the values for z and I got the values for y. So now I'm going to go to number 1 and I'm going to plug in 150 for y and 200 for z. Right? I subtract 350 from both sides. I divide. So we already have x equals to 220. So the answer was 220, 150, and 200, right? These are the adults, teenagers, and preteens. This is the people who attended the concert. 220 adults, 150 teenagers, and 200 preteens. This is how you work these type of problems and how to relate them to the real life. I believe, guys, we're out of time, but this is the last slide that I did. Let me take you back to the host so they can finish this off.
Next week, we will have basic matrix operations and inverses. Thank you so much to Professor Alberto Isasi for presenting today. Thank you to the audience for coming and being a wonderful audience, and we hope to see you again soon. Thanks.